So imagine, just for a second, that you're rolling a trillion-sided die, like a literal physical die with a trillion sides.
I mean, good luck actually reading the numbers on that thing, right?
Right, exactly. But if it lands on a 1, gravity works exactly the way it's supposed to. Stars ignite, galaxies form, and, well, you exist.
Yeah.
But if it lands on literally any other number, the universe is just this dark, frozen, expanding void of nothingness.
I don't know.
So what are the odds that we just happen to roll a 1?
I mean, statistically speaking, 0. It's absolute 0.
Right.
Unless, of course, that die is being rolled an infinite number of times, like in an infinite number of other universes, just constantly playing out every single possible mathematical outcome.
And that mathematical inevitability is exactly what we're unpacking today. Welcome to today's deep dive. We're pulling from this really fascinating excerpted discussion titled Time Traveler's Paradox.
It's a great source.
It really is. And our mission today is to look at reality at its absolute largest conceivable scale, which is the multiverse. We want to strip away all those, pop culture sci-fi tropes. We're going to figure out what modern physics actually suggests, why our human brains fundamentally reject the idea, and honestly what it means for you. Because whether you're a hardcore science buff or just someone who looks up at the night sky and wonders, this is going to challenge how you view your place in everything.
Because the reality of the actual physics is far stranger and honestly much more isolating than the fiction you see in movies.
Oh, absolutely.
To even begin grasping it, we have to completely redefine the boundaries of what we can physically interact with.
Okay, let's unpack this. Humanity has this relentless habit of constantly pushing the horizon of our questioning.
We always want to know what's next.
Exactly. For thousands of years, the biggest mystery was literally just, what's beyond the ocean horizon. And then we figured that out. So we looked at the planets.
Right, and then the edge of the galaxy.
Yeah. And now cosmologists are asking what lies beyond the universe itself. But wait, semantics here. Doesn't the word universe literally mean everything?
Well, yes, in everyday conversation, it does. But cosmology presents a much harder barrier than just crossing an ocean.
Because of the speed of light.
Exactly. We aren't just limited by our telescopes or our technology. We are limited by the speed of light itself. What's fascinating here is that the multiverse isn't just one monolithic theory. People talk about it like it's a single idea, but it's really a collection of several different scientific possibilities. And modern astrophysicists are very specific that they are only ever talking about the observable universe.
Right, because there's a hard speed limit. The universe is what, roughly 13.8 billion years old?
Give or take, yeah.
Which means we can only see light that has actually had 13.8 billion years to travel across the cosmos and hit our telescopes.
Right. And that speed limit creates this literal sphere of visibility around the Earth. The edge of that sphere isn't a grow wall out in space, it's a horizon of time.
Wow. A horizon of time.
Yeah, it's bounded by the cosmic microwave background, which is just the afterglow of the Big Bang.
Yeah.
You literally cannot see past it because the light from anything beyond that point it simply hasn't had enough time to reach us yet.
Which creates this brilliant visualization that the source material relies on, which is the bubble.
The bubble analogy is so helpful.
It really is. So imagine we are essentially trapped inside this spherical bubble of observable light. If you look at the inner wall of that bubble in every possible direction, it just looks like the absolute edge of existence.
And, the neurological temptation is to just assume that your bubble is all there is, because it represents the totality of your available data.
Right. If you can't see it, it doesn't exist.
Exactly. But think about it. If you stand in a dense forest and you can only see 50 feet through the trees, you don't assume the entire physical world ends at 50 feet.
You assume there are more trees.
You assume there are more trees. So cosmology suggests our observable bubble is just floating in this vastly larger, potentially infinite ocean of space.
Okay, but an infinite ocean of space with more stars is one thing. How do we jump from there is space beyond what we can see to there are entirely different universes with completely different laws of physics?
That's the big leap.
Right, and the reading makes a point that honestly blew my mind. Like you said earlier, it's not just one theory. The multiverse actually emerges independently from the mathematics of completely different branches of physics.
And the craziest part is they aren't even collaborating to find it.
Really?
Yeah, you have cosmologists studying the Big Bang over here, and quantum physicists studying subatomic particles way over there, working in completely different silos, yet their mathematical models just keep pointing to the exact same bizarre conclusion.
See, this is where I want to get into the actual mechanics. I want to
Hmm.
spend some time exploring how these theories work.
Right.
Because people always throw around the phrase, the math points to it, as this buzzword, but without any real explanation.
It becomes a cliche.
Exactly. So let's start with cosmic inflation. How does the model of the early universe somehow create a multiverse?
Well, cosmic inflation was introduced to solve a lot of observational problems with the standard Big Bang theory.
Okay.
The math dictates that in the incredibly brief fraction of a second after the universe was born, it didn't just expand normally, it expanded exponentially. It stretched out perfectly flat at a speed way faster than light.
But, and here's the kicker, the equations governing that exponential expansion suggest that it doesn't just stop everywhere all at once.
Right, it stops in localized patches.
So the analogy I love is the bread dough. Think of the overall fabric of space-time as this giant loaf of bread dough rising in an oven. The dough is perpetually expanding, just growing infinitely larger. But as it expands, little pockets of gas form inside it.
That is such a perfect visualization for eternal inflation.
Yeah.
Absolutely. Because the expansion in those specific gas pockets stops, and they basically crystallize into stable, localized bubbles. So our entire universe, I mean everything, from the cosmic microwave background to the supermassive black holes in distant galaxies, is just one pocket of gas that stopped inflating.
While all the dough around us just continues to stretch out forever.
Exactly.
And because that dough between the bubbles is expanding faster than the speed of light, these bubbles can never collide, right?
Never. They can never communicate. They are completely causally disconnected realities.
Okay, so that's inflation. But then the source says you have to combine that inflationary dough with string theory.
Right. And string theory operates on a completely different premise entirely. It's trying to reconcile gravity with quantum mechanics.
By replacing point-like particles with, like, tiny strings.
Exactly. Microscopic vibrating strings of energy. But the mathematics of string theory completely fall apart unless you introduce extra spatial dimensions.
Wait, extra dimensions?
Yeah,
Because
yeah.
we obviously only experience 3 spatial dimensions, right? Like
Yeah.
up, down, left, right, forward, back.
Right. But the math requires 10 or 11 dimensions.
10 or 11.
Yeah. So string theory requires those extra 6 or 7 dimensions to be curled up or compactified at incredibly microscopic scales.
So tiny we can't see them.
Exactly. And here is the mechanism that really matters. The specific geometric shape of how those hidden dimensions fold dictates the physical laws of that universe.
Oh, wow.
The way they fold determines how the strings vibrate. And how those strings vibrate determines whether you get an electron or a quark or a photon.
So the folds basically write the rule book for the physics.
Mm-hmm.
But the equations don't point to just one way to fold those dimensions, do they? The math allows for something like 10 to the 500th power different ways to fold them.
Which is a number so big it's practically meaningless to a human brain. But yes, which means there are 10 to the 500th power mathematically valid ways for a universe to be constructed.
Okay, so when you smash those two completely separate theories together, you get a perpetually expanding loaf of dough plopping out infinite bubble universes, and string theory dictates that every single one of those bubbles could have completely different internal physics.
Exactly. It is a breathtaking architectural model of reality.
Wait, hold on. You're laying out this incredibly elegant architecture, bubbles and dough, folded microscopic dimensions dictating physics, but we have zero direct observational evidence.
None whatsoever.
None. And the sources are really transparent about this. We cannot see them, we can't measure them, or interact with them. I mean, if I went to a scientific conference right now, proposed a radical new particle, and admitted I had absolutely zero physical proof, I would be laughed off the stage.
Oh, without doubt.
So how is proposing an infinite number of invisible universes, not just philosophy, masquerading as physics?
It is a fiercely debated criticism, for sure, and it gets right to the heart of this sort of epistemological crisis in modern science.
Right.
But the crucial difference between your hypothetical particle and the multiverse is that the multiverse is not the hypothesis.
Okay.
It's the unavoidable mathematical consequence of hypotheses that we actually do have evidence for.
Oh, I see.
Yeah, we have massive observational evidence for cosmic inflation. The temperature distribution of the cosmic microwave background perfectly matches the predictions of inflationary models.
So we have observational proof of the engine, but we just can't see the exhaust.
To put it another way, it's like finding the architectural blueprint for a massive 100-story skyscraper. We are trapped on the ground floor.
Okay, I like this.
The stairwell is bricked up, and we can never, ever go upstairs. But the mathematics of the blueprint perfectly dictate the load-bearing walls, the electrical grid, and the plumbing of our floor. Every single physical test we run confirms that the blueprint is utterly flawless.
Right.
This raises an important question. When that exact same blueprint dictates there are 99 more floors above us, we have to take that mathematical implication seriously, even if we can never see them.
Because discarding the 99 unseen floors means throwing out the blueprint that flawlessly explains the floor we're actually standing on.
Precisely. You cannot cherry-pick the math. And this tension brings up what the source text calls the blank slate theory. Yes.
Which is this vital philosophical framework for how science actually progresses.
The blank slate theory is such a humbling reminder about the generational transfer of knowledge. Like, no human being comes into this world with an innate understanding of quantum fields or string theory geometry.
Right. We definitely don't inherit the math genetically.
We don't. Every single generation arrives as a completely blank slate. They have to start from zero, learn all the accumulated evidence, and stringently differentiate between what is mathematically possible and what is confirmed reality.
And theoretical physics lives entirely in that gap between possibility and proof. We literally have to teach ourselves the absolute boundaries of reality every generation.
Yeah.
We map out the borders of the mathematically possible, fully knowing it might take 1,000 years for the actual observational evidence to catch up.
But, accepting that mathematical blueprint creates a massive conceptual hurdle for us as observers. Because if we accept that there are 99 other floors, we naturally have to ask what those floors actually look like. And the answer is that they would likely be totally unrecognizable and incredibly hostile.
Here's where it gets really interesting, because sci-fi movies have really done us a disservice here.
They really have.
When people hear multiverses, they immediately picture a universe where, like, they're wearing an eye patch or where the dinosaurs never went extinct. They picture this very human-centric drama.
Always.
But altering the physical constants of a universe-like happening, changing the shape of those hidden string theory dimensions, creates realities that are deeply, deeply alien.
Right. Let's look at the strong nuclear force, for example. That's the fundamental force that binds protons and neutrons together inside the nucleus of an atom.
Okay.
The math suggests that if that force is even a tiny, tiny fraction weaker in another bubble universe, atoms simply cannot form. The protons would repel each other way too violently.
Which means you never get hydrogen.
Exactly.
And without hydrogen, you never get star formation. Without stars, you never get the nuclear furnaces that forge the heavier elements, like carbon or oxygen.
And without carbon, you never get biology.
You just get this infinite, perpetually expanding expanse of cold, dark nothingness. Like a universe filled with absolutely nothing but subatomic static forever.
Or, imagine the exact opposite. Imagine a universe where gravity is just slightly stronger.
Okay.
Stars would still ignite, but the crushing gravity would cause them to burn through their nuclear fuel in a matter of millions of years instead of billions.
Wow. So they just burn out instantly.
They would explode in supernovas long before a planet could even cool down, let alone before evolution could ever have a chance to start. So the vast, overwhelming majority of these bubble universes could be completely dead, sterile voids.
There is a line in the source material that captures the weight of this so perfectly. Reality is under no obligation to be limited by human imagination.
I love that quote.
Reality is under no obligation to be limited by human imagination. It's a terrifying thought, honestly. But history constantly proves that every generation discovers phenomena that previous generations thought were totally impossible.
Right. I mean, like just a few centuries ago, the concept that invisible electromagnetic waves could carry a human voice across the globe instantly.
Yeah, that would have been considered impossible magic.
Totally. And now it's just the basic infrastructure of how you are listening to this audio right now. Our imagination is entirely bounded by our local historical environment.
And there's a harsh neurological truth to this that the text explores. We evolved to, throw rocks at antelope. We evolved to track predators on the savanna, forage for berries, and navigate these complex tribal social structures.
Exactly. The human brain is a piece of biological hardware highly specialized for a very narrow band of reality. were built for medium-sized objects moving at medium speeds in 3 visible dimensions.
Right.
It did not evolve to conceptualize infinite realities or 10-dimensional spaces or scales of time that span hundreds of billions of years.
We fundamentally struggle to comprehend it because we're basically trying to run next-generation universe simulating software on hardware built for the Stone Age.
That's a great way to put it.
The brain just reaches a point where the scales are so massive, the numbers just turn into static.
Which naturally brings us to the inevitable paradox of this entire discussion. Grappling with these unimaginable scales really forces us to look inward.
Yeah, it does.
If reality is this vast, this alien, and this infinite, it creates this crisis of meaning for human existence.
Right. If the universe is a perpetually expanding loaf of dough popping out infinite bubbles, and most of them are sterile voids, why are we lucky enough to be in one that isn't?
Oh.
If there are
Yeah.
infinite Earths playing out infinite mathematical possibilities, does this specific Earth even matter? Like, does infinite abundance diminish our value?
It's the deepest philosophical tension in cosmology right now. But if we connect this to the bigger picture, the answer the source material provides is a resounding no.
Thank goodness.
Right. It uses this beautifully grounded analogy to counter all that existential dread. Just think of a flower.
Okay, so if you are standing in a massive field containing millions of flowers, stretching as far as the eye can see, does the sheer overwhelming abundance of those flowers make this single one you're holding in your hand any less beautiful?
No, of course it doesn't.
Because value does not derive from scarcity. It derives from existence itself. The structural complexity of that flower, the biology of its petals, is inherently meaningful regardless of how many others exist.
Exactly.
Even if there are infinitely many universes, it doesn't erase the profound complexity of the fact that this specific one formed perfectly to allow us to exist.
But to truly appreciate that, we have to confront a massive cognitive bias. We have this visceral, hardwired need to feel like we're the center of the story.
We really do. I mean, every sight you see, every sound you hear comes to you from a central point of perception located directly behind your eyes.
Right.
You are quite literally the center of your own observable universe. And historically, humanity just projected that neurological bias outward onto the cosmos.
We looked at the sky and assumed the Earth must be the center of the solar system. Then we looked deeper and assumed our solar system was the center of the galaxy.
And then we assumed the galaxy was the entirety of existence.
Right. Every major cosmological discovery in human history has been a deeply uncomfortable process of demoting ourselves from the center of things.
But the realization of the multiverse, like even just the mathematical blueprint of it, shouldn't be viewed as a demotion that makes us insignificant. Stripping away the illusion that we are the center of everything is actually the key to unlocking true scientific wonder.
Oh, absolutely. Once you realize how hostile the math is, how easily the strong nuclear force or gravity could have been tuned to create a lifeless void, the fact that this specific bubble has the exact, precise tuning required for carbon-based life to evolve is staggering.
It totally shifts the feeling from insignificance to just sheer miraculous improbability. We are these tiny, fragile, biologically limited creatures sitting on a relatively small rock, orbiting a completely ordinary middle-aged star in a quiet suburb of an average galaxy. And yet somehow we have evolved the capacity to sit here, do the math of the multiverse, and decipher the invisible architecture of reality itself.
The source actually quotes Carl Sagan on this exact feeling, and it remains one of the most powerful ideas in modern astronomy. Sagan noted that humanity is a way for the cosmos to know itself.
We aren't just in the universe, we are the universe observing itself.
Exactly.
It implies that human curiosity isn't just a quirk of primate psychology. Curiosity might be one of the universe's greatest, most complex creations.
I love that.
It is the mechanism by which a 13.8 billion-year-old system finally wakes up and tries to figure out how it works.
When you frame it that way, understanding that we might be just one universe among many doesn't make our home feel less significant. It highlights the absolute miracle that we are here to observe it, measure it, and marvel at it.
So, as we bring this deep dive to a close, we have to look at the ultimate trajectory of all this knowledge. We map the physical boundaries of light. We follow the mathematical blueprints of inflation and string theory. We confront our cognitive biases.
We do all that, yeah.
But the text reminds us of this humbling historical pattern. Every single generation believes they're the ones who are finally approaching the final truth of reality.
They always think they're turning the final page of the book.
But reality never gives us a final page. It only ever reveals deeper, more complex chapters. which suggests there might not be a final truth about the physical structure of reality.
And that leads to what the source calls the dangerous next step in human questioning. Because if we accept that there might be a multiverse, the next major leap in our curiosity isn't about where reality exists or how many bubbles are in the dough.
The next leap is questioning why anything exists at all.
Right. Moving from how does the mechanics of this incredibly complex cosmic machine work to why is there something rather than nothing?
Yeah.
It is a question so immense, so foundational, that even the original mathematical thinkers in our source material hesitated to tackle it.
It's the ultimate philosophical cliff edge. We started today looking at a trillion-sided die, imagining the staggering mathematical odds required for a universe to support life. We've explored the hidden dimensions, the expanding void, and the limits of our own biology.
We've mapped out the possibilities